discussion, video as the new language for real-world decision-making. This is, in my opinion, the it's a road sign that points into the right direction. It points into what I think is a breakthrough for robotics. In a nutshell, what the authors are suggesting is use Gen AI to create realities that then can be used as data sets for trajectories for robots. The fundamental problem with robotics is that we cannot do reinforcement learning at scale because it takes a long time to learn, picking up a glass, driving a car. There's too many, the search space is too large, and you just don't have the luxury to try and fail so many times in the real world. It's too expensive and too dangerous. So people like Sergey Levin and a lot of people, Chitendra Malik and the people at Georgia Tech and CMU and some people at MIT and of course Stanford, those are kind of the places that I'm familiar with. They're working on solutions to that. One solution is offline reinforcement learning. So you have a data set that you collect maybe in a crowdsourced way, and then you use supervised learning, which is kind of the same thing, to learn certain trajectories. But this paper here really gets to the heart of what I think is the solution, which is you create a simulation which is embedded in the real world through generative AI, and then you use that simulation to train the robot. This is not even on podcast. It's February 29, 2024. This is Krim Telko. This is the second installment of today. We are up 40 basis points. The market is up 50 basis points for the year. We are down 9.7%. The market is up 5.5%. We're underperforming by 15.2%. Now let's jump right into it. This is a paper discussion. This is something that we started doing in particular after NeurIPS. I think arXiv is the new, it's the internet of science. It's amazing. You have access to papers that are, whether they're reviewed or not, that's not even important, but it's an idea generation. It's almost like a Twitter for science, if you will, where you have access to the actual papers. And for us at Orange Capital Partners, we don't go into the nitty-gritty of reproducibility, of technical applications. We usually read the introduction, we read the methodology, and we read the discussion. This is kind of where we live as far as reading arXiv papers. It's very inspiring because you get exposed to ideas, and a lot of ideas are they're just what they are, ideas. But it's very interesting to follow science that way. And I've done this in the past when I was in college and when I did my master's through back then, traditional reading publications. But in my field, which was in college economics, and then my master was my MBA, I read papers that have been written probably years before they were published because it just took so long to publish them. And this is the beauty about arXiv. The time to market, if you will, is much faster. So this paper was published in arXiv a couple of days ago. I think it's going already. It's making a pretty big splash because this idea that we have generative video as a trajectory for robotics, in my opinion, is very powerful. So what does it actually mean? So let's start with the concept of video. Well, why is video interesting for robotics? Well, because we have one modality in robotics, which is not the only one, but it's the one modality that seems to be working pretty well. It's that we use the sensory system of the cameras to feed pixels and then use those pixels as data sets to make decisions. What is a robot? A robot is an embodied decision-making agent. So this paper is actually in the series of foundation models for embodied decision-making agents. I haven't named it like that, and I might name it like that. It's not important here. Let's just leave it at that. I guess I should name it. So this is part 6, I believe, of foundation models for embodied decision-making agents. This paper is crucial for that because it really captures I think the key to many solutions to problems that are prevalent in the world of robotics. What is the solution? So we're creating a data set that is based on video, and the video is the form by which we train the robot. Why video? Because video helps us understand complex environments. And as an embodied decision-making agent, I am moving through the real world. And the real world has a lot of things that language models could not capture very well. You know, I'm approaching the entrance to a garage. The entrance is downward sloping. I can go straight, right, and left. On the right side, I have a door. On the left side, I don't have a door. I have a stop sign. I can do a lot of that stuff, in language, but I don't think it's enough. I think I need more than that, and video captures that really well. Now, to mention, let's say, Jensen Huang's recent comments on Gen AI, I can use language potentially to prompt a video and then have the video finish in a sort of generative way. Now, fundamentally, what I'm trying to say and what the authors are going at is the following. Like, let's say we're training a self-driving car. The problem with the self-driving car is that you have many trajectories that a car can take. For example, driving on a road can have many trajectories. There is, whether it's a Gaussian distribution or not doesn't matter. There's certain distribution of events that can happen on roads. And of course, that depends on the road. So whether I am in New York City or whether I am on Highway 280 between Palo Alto and San Francisco, it will change the distribution of events. In the New York City, if I'm going down Fifth Avenue in New York City, I will have, taxi cabs, pedestrians, but I probably won't have deer. I won't have heavy rain in February and then no rain throughout the rest of the year. Like, things are different in Palo Alto than in New York. The beauty of generative AI is that I can generate many trajectories. And I think that in itself is still an unsolved problem. So we have Gen AI models such as Sora, Gemini, and many others that generate videos. We have, for example, not been able to solve generative videos above a certain time frame. We can't do movies yet and things like that. But that's probably just a matter of time. The concept is still the same. Imagine we have the ability to generate a video with a road and the car drives down that road in many millions of scenarios. In that sense, we could have a Monte Carlo search which goes through all these scenarios and then trains the car to drive in all these scenarios. We could even have Harry Potter scenarios, surrealistic scenarios. We could have, things popping out of the floor and falling from the sky and whatnot. All kinds of things with low probability, but still we could have them. In a sense, if we virtualize reality through generative video, we can have a multiverse where everything that's allowed under the laws of physics actually happens. And we could train a robot to drive under these conditions, which in my opinion is pretty much what the actual reality looks like, at least to our knowledge today. So we would have a distribution of events, driving on Highway 280, but there is a very small but still non-zero probability that the sky will be black during the day, which happened a few years ago because of wildfires. There is a non-zero probability that it rains very, very thick hail, and so on and so forth. Like you could have scenario. You don't have to go into surreality and things like that, but you can have whatever's allowed in the laws of physics. Now, again, the authors also mentioned that we are still in the world of how can we even generate good videos. But the concept here, and this is what this paper really is discussing, the concept is a good one. How we actually generate those videos, that's a different conversation. And whether we should use what kind of distribution of events we use and how we generate those, whether we use diffusion or we use you know GANs or other things, that's still up in the air. Maybe diffusion is the flavor du jour and it will change. But the concept is not going to change. And this is really powerful. So once we have video as the primary source of data, we can now use offline reinforcement learning, maybe coupled with imitation learning and other maybe new ideas within the realm of reinforcement learning to execute the task of training the robot how to drive, or training the robot how to pick up stuff and work in environments such as factories. There's a lot of question marks in whether the transition from sim to real can happen. That is a problem that also needs to be solved. But what this paper is addressing is the concept of generating enough video material to even learn in sim. And this is what's so beautiful. I want to finish this episode with another comment that I picked up yesterday in one of the events, and that was Dorsa Sadiq's lecture on robotics. She was talking about reinforcement learning from human feedback, and I will discuss her lecture in the events discussion tomorrow or on Saturday. As I usually do after the week is over, I discuss all the events, and since I'm back here in Los Altos, I will discuss all my events that I attended and the paper that I discussed and all that stuff. But I want to point this out because it's related to the paper about generative video, and it's the following. What Dorsa was talking about is the idea that we could have a fleet of robots that could be used as the basis for a foundation model that we can pre-train and then use that as the basis to fine-tune on new tasks. Now, Dorsa, her academic family tree goes back to Berkeley, so I'm not surprised that that's how she thinks, because the Berkeley crowd, particularly Sergey, but others too, I think they have this idea, and I've heard this in public speech, so I don't know what's going on under the hood in the private settings, but they believe that they should already prepare for a world where we have plenty of data from robots, the same way we have data on the internet, written data, so we can then create large language models. Let's say we could have large robot models from based on data sets from robots. And I think this is related to this gen video to sim type idea, because in both cases, what we're really trying to do is have a unified data set for robot learning. And this is also what the authors point out, by the way. It's the ability to generate video in a consistent way. It's the ability to generate video also with consistent user interfaces. This is obviously a much harder said than done, particularly once you leave the self-driving car space and you go into, let's say, the humanoid robot. You're questioning, okay, well, how long is the arm? What are the fingers? What's the UI actually? Is it the eye camera? Is it the camera on the hand? Like, let's say that's what Shuren Song was talking about on her last seminar talk here at Stanford, where she put cameras next to the arm of the robot. So we have to unify all that. And I think, again, if we could have video generated, we could actually even have a distribution of video cameras all over the robot, maybe within certain, spatial, deltas, and therefore also again have a distribution of video and eye pictures or video perspectives, and then sort of sample from there and learn based on that. So once we go into in silico design of data sets, we have a much, much bigger set of possibilities. We also have a much bigger search space, but it becomes a Moore's law slash, NVIDIA problem. What I mean with NVIDIA is it's not just Moore's law anymore. It's more than that. We have to find much more efficient ways to do compute. We have to solve, uh, wall clock time problems. But once the problem is at that level, we can use all the electrical engineering and all the work in comp sci and engineering and algorithmic work to solve all these issues. And we're going to progress much, much faster than today, where we're in this bespoke environment. It's like alchemy with robots, where each lab is working on their own robot, and once the thing breaks, it takes 2 weeks to fix it and all that stuff. Imagine we have in silico creation of data sets and training, and then we just have to find a way to transition from sim to reality, which is a problem in itself, and the authors talk about it, but we could have a much faster, a much more efficient trajectory. So to summarize this paper, video as the new language for embodied decision-making agents, which is part of this episode is part of our series of foundation models for embodied decision-making agents, and it amplifies the importance of simulation. And the breakthrough in simulation comes through video generation, and we can now start building massive data sets for offline reinforcement learning based on video data and solve the robotics problem and solve all the intricacies of robotics, the lack of scalability, the lack of unified UIs. All of these things can be solved by using in silico design and then finding ways to better transition from sim to real.